Hi everybody. Welcome to this webinar on Apache Kafka and Spark streaming, and basically just trying to explore how exactly Kafka sits nicely in the streaming kind of solutions, and how can it help you to design some of the streaming solutions together. My name is Vishal, and I hope all are able to hear me. And are you all of you able to at least see the screen which is being shared? If you are, then that would be great if you can just confirm. Great. Thanks, guys. Thank you. Thanks, Rajat. Others. Thanks a lot. Uh, Welcome, guys. It's just sharp 8:30, and we're gonna wait for another couple of more minutes. Let others to join, and then I hope that should be fine, right? And welcome again to the people who have just joined us in last couple of minutes. So again, my name is Vishal, and I'll be just taking this webinar about the use case of Kafka and how exactly, it's not just about Kafka part, and it's not just a promotional sort of a webinar, or it's not kind of a sales pitch wherein we are just talking about, the upcoming Kafka course and all. It's not about that. It's all about how exactly it's transforming most of the analytics systems, how exactly it is being used and all. So before I come to the agenda or the topics for this webinar, which we have in kind of, let's say, in next 1 hour, let me just give you a very quick brief about myself. You know my name already. I'm having almost more than now 12 years of experience overall, and since last more than 5 years, I'm working in now you call it as big data domain. When we started, we used to call it as a disruptive technologies set. And like most of you who might already be working in this area, my journey also started in Hadoop. Now I find myself doing more of the implementation of something called Lambda architecture, if you have heard about it. So that is something which I find myself doing. When it comes to that domains perspective, it's mostly into the retail domain and into the finance domain, wherein I have worked most. There are a couple of projects which I've done for the telecom domain as well as for healthcare, but yes, they are like way negligible as compared to the other domains. So I think that should be good enough about my introduction, and let's just quickly talk about the agenda or the things which we plan to use or which we plan to discuss in, let's say, in coming 1 hour. So guys, first thing first itself, I'm not sure how many of you have, let's say, done a bit of Googling or all, but at least the very fact that there are people who are attending this webinar, you must have done, or you must at least be aware of Kafka, right? So we'll just take a fresh take on what is Kafka. I'm sure if you just do a bit of Googling, you type Kafka, you'll find Kafka Storm, Kafka Spark, Kafka Hadoop, Kafka Analytics, Kafka versus RabbitMQ, and things like that, right? So let's just talk about it, right? What exactly it is, and then the next question comes: why do I need it? Well, again, it's not about why I need Kafka. Probably the larger question is, why do I need Kafka when I have other queuing systems which are available? Because Kafka at the end of the day, it's a messaging system altogether. So why are we talking about Kafka? What makes it different as compared to the other queuing systems which are available? We'll just quickly talk about that. And again, we will still keep our discussion at the higher level in the interest of time, which is just limited 1 hour, which is available right now. But we'll definitely have a look of different Kafka components, or so-called Kafka architecture. In fact, that forms even the coverage of the course also, which will be which is available with Edureka there. And then comes about what actually makes Kafka work the way it works right now, right? So that is something which we'll talk about. And then which companies are using Kafka? Well, more than about which companies are using Kafka, it's about how exactly they're using, right? Well, then there would be the last part. I think there seems to be a small mistake here. It says Kafka and Spark integration, but I would go for a larger topic. It's about how exactly Kafka is being integrated with the big data ecosystem altogether. Spark being just one player. So Kafka can be integrated with Spark, Kafka can be integrated with Storm, Kafka can be integrated with Hadoop and all. So in generic, we'll do that. And if the time allows, I cannot really, promise on that side, because there is one, after this, have to jump into another meeting. But yes, if the time allows, I would definitely love to show you something in terms of your Spark streaming part of it, wherein, let's say, if you just run a streaming application, how exactly Spark reads it from the streaming side of it, and that stream can be generic. That stream can be generated from, that stream could be generated from the outcome of your Kafka topics altogether, or it might just be coming from, let's say, a particular, and any other streaming source altogether, right? So that is something which we'll just try to see. But yes, before that, let's just try to focus on the other agenda items altogether, right? So far so good, guys. Are we all good to go? I think there is a question from Upender when he says, would you cover Lambda architecture using Kafka and Spark in actual course? Well, good question. I would say yes, because there are case studies which are included in this course. So of course, in that case study part wherein we are talking about the integration thing and all, at that time, this aspect would definitely be covered. Right, Upinder? I hope I answered your question. And at the same time, guys, let's just get started, right? Okay. So question comes, why Kafka? Okay. Rather than saying why Kafka, let us generalize the question a bit more. Why Kafka when I have heard about the other queuing systems? Hope all of you have heard about these systems, right? Or some of them, right? ActiveMQ, RabbitMQ, ZeroMQ, Hornet Queue, and then who hasn't heard about JMS, right? So all of these, systems are there. And in fact, if any of you have worked with Storm, right? In fact, it internally uses ZeroMQ, if you could recall that part, right? So the whole point is there are a lot of queuing systems altogether. So the question is, it's not just that why Kafka. The question, or the larger question, is when you already have so many messaging systems which are available, either centralized or decentralized, why should you talk about Kafka? Are we saying that other systems are not good? Okay. If that is the case, then the simple answer is they're all good. They're all good. It's not about, like ZeroMQ versus, we are not talking about that. But all of them have their own different use cases. There are some certain use cases when it comes to specifically the cases of using the data or consuming the data via streaming. At that point of time, Kafka is something which scores way better than other queuing systems altogether, right? Analytics or all of these kind of data is generated or is based on the real time, or rather than real time, I would say on a certain window of data itself, right? Because you would definitely not like to do this analysis based on the data, right? You would definitely not like to do the analysis of this data based on, let's say, whatever data is available as of 2 days before to you, right? So that is something which becomes the natural playground for Kafka. The other part, your performance metrics, again, if that was more of a fancy kind of an example, but when you come to the more conventional examples, right? The more conventional examples are when you have to, let's say, do a bit of performance matrix calculation altogether. Your memory uses, CPU or IO heavy operations are going to be higher, right? Or some of the application specific statistics if you have to collect, right? From the, just a second, right? So if you just talk about, let's say, you have a web page, right? So the time which is typically taken to load a web page, or the time or the number of requests which are being made altogether, right? Or the number of hits on a particular page or URL. Typically, we call that as a click stream data. And the frequency of such data is quite high. That is multiplied by the number of concurrent users who are visiting your website, right? So then you're talking about the natural playground for Kafka is such use cases wherein you have these small bits of data which is being generated very frequently from multiple sources, and it just has to be either, if not persisted, it just has to be consumed, right? Whether you want to persist it or not, that's a secondary choice, but at least it has to be consumed in a distributed fashion altogether, right? Are we all good up to this point? Just a sec. Upendra says that he's having some trouble while listening to me. I hope others are able to hear me properly, right? Sure. Okay. Okay. Seems like it's a bit this thing, because there are some guys who are already confirming that yes, they are able to hear me, and then there are few guys who are saying that yes, so that might be your individual endpoint. Sometimes the bandwidth fluctuation happens, guys, right? So that happens sometimes, but nevertheless, in case if there is some portion which is being lost, I will definitely like to repeat that for you. No issues on those sides. Is that okay? Yeah, so echo and all, definitely, Vivek, then there is definitely some problem at that end, because I can clearly see from many people who are saying that yes, it's quite clear. Right, right, exactly. So no problems. Let me just quickly. So yeah, I was exactly at the place wherein we were talking about the use cases, and then we were talking about the use cases wherein either you have some fancy use cases, as we just told about some of the events which are happening real time, or you talk about some of the machine generated kind of a data, right? Your click stream data and all, wherein you might have to do the analysis, or if not the analysis, you just have to just capture the data or probably persist or process that data, right? So that is something that is something which are the very obvious use cases for I would say Kafka. But yes, whatever scenarios we just discussed, right? What is the common thing for all of? So I just told you that these are the natural ground, but what was the pattern? What was a common problem point, or rather than problem point, I would say pain point across all of these scenarios? The first point itself is that your system has to be scalable. You are talking about millions of concurrent users and their click stream data. Well, your system better need to be scalable altogether. You cannot really think of any centralized system altogether, right? And definitely not a centralized queue. It's just simply gonna die altogether, right? That is first part. Reliability of the messages. Well, this is something wherein I would say that it's a tunable part, right? Reliability of the messages, this is just an open question that if out of several millions of messages, if I lose a small number of messages, is it going to be fine with me? Is it going to be fine with me? Or is it like I cannot really afford that, right? Because that completely determines the entire performance of your system altogether. If you're talking about the tunable reliability, it's something which you can live with, then you know the kind of performance which might come out of the system versus the place wherein you have a zero loss policy, that would be slightly different, right? You're talking about distributed systems because, well, you are just creating the clickstream data. I'm just giving you some example, right? So you're talking about the clickstream data and all that stuff. Well, this data might be coming from multiple producers altogether, right? This might not just be single web page altogether. This might be the several sections of your websites from which the data is being generated, and at the same time it might be consumed by multiple consumers, not just the real-time analytics kind of a system from the there might be other departments also which might be interested. Let's say you have some of the programs which are just running for the marketing part of it, then there might be some of the places which might be looking for the the performance part of it. So there are different teams which might be consuming these data. So the whole point is that your entire setup is going to be distributed, be it from the side of the producers of the data as well as from the side of the consumers of the data. And of course, no prizes to guess that it has to be a high throughput data. Of course, the kind of again, you're not talking about the JMS kind of standards, because if you really go for that, it's basically you're talking about an overkill kind of a situation, right? Because here the JMS standard simply says that each message has to be acknowledged back. Well, each message has to be acknowledged back is something wherein you would like to kind of tune it a bit, right? Because you cannot really stand with the very same thing when it comes to the millions of messages which are coming per second, right? So that is something which is kind of this is something which is a very common pattern across whatever scenarios which we discussed, right? So now comes the Kafka part. Care of these scenarios, but yeah, before I come to that, I think there were few things which are, yes, Ganga, exactly. So guys, one thing, right now when I'm just taking this webinar, there are a lot of people who are raising the questions. I will just try to answer few of the questions whatever the time permits within this. And exactly, as I can see that, yes, I think Gangapani has kind of typed some 4 or 5 times. Hello, you there? Right. So let me just do one thing. Probably you are right now talking from the perspective of the system configuration or something, if I'm right. So probably, is this okay if I just take this configuration part, because this is something which is very, very, very specific to your requirement. Is this okay if I'm able to take it at the end of it, please? Right. But yeah, the point is, if you're just talking about just a second, because probably by the end it might be a bit difficult for me. Let me just wrap it up right now. You say, what is the example configuration of the scalable system altogether? See, it completely depends upon your specific requirement. You're just talking about EPS receiving data is what, 200,000 per second. If that is something which you're talking about, then I think just hold on. There are few more slides which will just talk about a bit example configurations. So at that time, I'm just going to show you some indications there, right? And again, it completely depends upon the size of your entire message which is going to be passed, and plus the RAM configuration which is available, right, at the nodes where you are going to set up your Kafka, because it's completely RAM driven system, right? So anyway, I'll touch back. I'll come back to this point, right? Again, so now coming back to the Kafka part here, right? So it's all about LinkedIn. Again, we don't really need to talk about the kind of volume which they typically deal with, right? But ultimately, LinkedIn kind of developed this system because they had some certain scenarios, right? Of course, they are sitting on the top of a huge amount of data, right? So they have to flow this data eventually to their data warehouse, right? Another thing, the batches of the data had to be sent for the Hadoop analytic systems altogether, right? Which typically run their batch jobs altogether. Not only this, there is a typical service layer, and if you talk about, you know, your hot or the speed layer in the Lambda architecture, so collection and aggregation of the logs altogether from, let's say, there are many services which are there in, you know, LinkedIn. So collecting the data altogether, and again tracking events like page views, etc. Typically, you get those kind of statistics, right? Your profile is being viewed by so and so. If you click by profession, by region, by title, and then there are several features, right? All of them have to be served back to the individual clients altogether, right? And then queuing for their in-mail messaging system itself, right? Another part, right? Your people search system, it has to be up to date, right? Because if you remember, if you have seen some of the settings that update or propagate your updates to your network or not, you can set it as yes or no altogether, right? So based on that, your updates have to be propagated, and at the same time it has to be consumed by the relative profiles altogether, right? So somewhere you are talking about a lot of data generation points which are right from your clicks to your updates, right? All of these are, we are talking about the different sources of the data generation within the application itself, and then you are talking about multiple consumers, right? It might be the consumers which are their Hadoop analytics jobs which are running on the back end, their recommendation systems which are running on the back end, or even the related profiles which are, let's say, just going and clicking on your profile. Are we getting up to the point, right? Are we getting up to the point wherein we are talking about multiple producers and multiple consumers? That is the kind of scenario, right, guys? I hope you can confirm that part, right? So these are few of the scenarios, right, which eventually led for a system like, right, a system like Kafka altogether. Some of the statistics, right, some of the statistics again, and probably this might give, I think probably Ganga was asking some of the things, right? You're talking about the way it is being used in LinkedIn itself, right? There are almost 350 plus Kafka brokers which are there, 8,000 plus topics. Again, we are talking about huge amount, 140,000 plus partitions, right? It's huge amount of the data, right? And you're like 278 billion messages per day. I mean, it's mind-boggling altogether, right? So these are few of the statistics which are, again, these are just for your reference. But whole point is, again, I would not like to spend much time here. It's about just a screenshot from you know, the architecture as of some timeline altogether, wherein from Kafka to Teradata, basically it's all about, you know, collecting the data from the different data sources from your website up to Teradata. How exactly data just flows, it just kind of gives you the idea. This entire slide deck is going to be available as part of LMS. So there is a nice link which we have provided. I would definitely request you to visit that link. Just have a look there, right? This is just for a reference. You know, you can do it in the leisure time. But yes, coming to the point, I think, yeah, before I proceed forward, I think there are one or two things. Can you post the URL right now? For that, I'll have to, yes. So Upender, what I'll do is, not just the URL, this entire slide deck is going to be available, right? Within few hours from this webinar, Upender, if that is okay with you. Or probably somebody from support team, guys, if you can just help Upender and others out there, right? So don't worry, you'll just get that. Right. So, very good question, Ganga. So again, a nice question from him. He just mentions that is the aggregation possible on the Kafka side? As per my understanding, it is only the powerful queuing system. It is a powerful queuing system with the nice batching or nice batching capabilities altogether. Batching and distributed topic capabilities altogether. Right, Ganga? It is not about the aggregation. Of course, this is not the problem statement for Kafka. Fine. So definitely the answer is aggregation is something which is not Kafka intends to do, right? Um yes, Sushil. So I'm naturally going to cover this part. So Sushil talks about, can you talk more about Kafka benefits of using these messages? So when we'll talk about uh, the architecture part or the way it is consumed in the analytics space, right? In the big data ecosystem itself, probably that part would automatically come there, right, Sushil? So just moving forward, and of course it would automatically be. We have to perform aggregations in other exactly. So yeah, so good point, Gangapani. What I would do is when I'll talk about Kafka in the big data ecosystem itself, at that point of time, some of your questions might either be answered or we can actually have that relevant discussion there, right? Makes sense, right, Ganga? Great. Now, let me just continue there. So at the end of the day, now we have just talked about, why Kafka, a few things there. Now let's talk about a bit of things in terms of, what exactly Kafka is. And now let's start getting into some nitty-gritties here. So at the end of the day, it's a messaging platform. We all know that, but it's a distributed messaging platform which follows the pub sub mechanism. Pub, publisher, sub, subscriber. So it just follows a mechanism which is more of a publisher and subscriber based kind of a thing. It's a universal pipeline. Have you guys heard about ESBs? Have you guys heard about ESBs? Enterprise Service Bus and all from those days, right? You can just think of this kind of, a bit, I mean, again, I'm not drawing the parallels here, but if you remember your subscriber mechanism, publisher and subscriber mechanism works almost the same way altogether. It's kind of a universal pipeline, which is based on the the normal so which have gone behind Kafka is, of course, first have this atmosphere. It is enabled near real-time access for to any data source altogether. And the best thing is it is basically it empowers your Hadoop jobs altogether, right? Guy can put the stream, so all the systems like Spark, like Storm has got its own spouts altogether, which are specifically the Kafka spouts. Similarly, when it comes to Spark itself, right? It has got its connectors for Kafka, which can read the data from a Kafka topic altogether, right? So these are few things, right, which which were some of the design goals altogether, right? Recap to you, or let me just do it right now. What we just mentioned is in first 11 slides, we just talked about the different use cases where Kafka is applicable, like your clicks, your real-time streaming applications altogether, and the places wherein you have to take some sort of highly scalable, almost real-time, high throughput kind of systems, right? And then we started just going a bit deeper into some of the Kafka terminologies, some of the Kafka benchmarks. That exactly is the place where, right? And you, yes, of course, Vikrant and others, all of you will get the slides also. So don't worry about that part. Okay, Rahul, that is the fastest which I can do for you in few seconds. Okay. Sure. Now, that is something which, so now coming to a bit of, Kafka producer or consumer performances altogether, right? Well, if you, what we are just trying to see is, if you see the producers, right? So accumulated produced messages in MB. And Ganga, if you are still there, right? Now you can actually see some part here, right? When we are talking about the MBs part, I think this should be able to give you some idea in terms of the hardware side of it, right? If you just talk about your 500,000, messages per second and all, right? How exactly Kafka performs in terms of, as compared to, if you see the, uh, this is the active MQ line. The other one, the red one, is the Kafka one. Okay, whereas like you have done the batch size as 50. If you just set the batch size as 1, it means at that point of time you're doing it per per transaction level. Then it's a different performance altogether, right? And then you talk about Rabbit MQ and all. So you can clearly see that it gives you that tunable kind of a performance altogether, right? Or when it comes to the consumption side of it, again, it's all about, you can clearly see that, again, all of these comparisons are on the comparable hardware. It's not about that, you are talking about different set of hardware and then trying to measure the performances, right? These are some of the things, right? Well, very, very quick about few things, right? That how fast, again, it is just to give you some idea, right? That if you're just talking about 3 cheap machines, well, cheap machines is not really the right term. You're talking about, let's say, the commodity machines. If you talk about some 3 commodity machines altogether, you might scale it up to 2 million writes, per second altogether, right? And when it comes to the test setup, so Ganga, I was telling you, right, that there would be some places where we would be giving you some idea altogether. So I hope you can see the kind of configuration which we are talking about, right? If you see the last line, 3 machines, you're talking about 6 core Intel Xeon, that processor, RAM is 32 GB RAM, and that's how it is, like for SD, hard disk and all that, and Ethernet thing, right? Ganga, I hope you are seeing this. But again, this is for a certain test setup, right? This is something which is gonna change drastically for you depending upon the source from which you are consuming the data, right? And the kind of processing which you are supposed to do, right? So those kind of things will just change for you a bit. So, but again, this is from the test setup perspective. This is how a typical kind of configuration looks like. But when all of the graphs and other things all said and done one side, but what exactly makes it fast from the writes perspective, from the reads perspective? The main reason for the faster performance of Kafka is its caching mechanism altogether. It persists the data to disk, but at the same time, if you remember, if any of you have spent some time on HBase and all, you have the caching mechanism altogether, right? So here also it uses it uses something called page cache altogether of OS, and basically you're talking about the RAM. And of course RAM operations are going to be faster when it comes to the writes as well as when it comes to the read part. Again, the data is read from the cache side, and again it is sent to the network socket. That's where it becomes available for any of the stream reading applications, like your be it your Storm or Spark kind of applications. They can quickly do this, and that's where that is something which makes Kafka so fast, right? Your page caching as well as network socketing available to this part, right? So these are the two things which make Kafka way faster as compared to the other mechanisms which typically rely on persistence of the data altogether quite a lot, right? So these are some of the things, right? Again, numbers are just, and again, these are the different use cases altogether. If your use case says no, that you have to let's say spend more time, or you have the replay of the message recovery is very, very important part of your system, then well, you are just saying that probably you would like to explore some other mechanism system altogether. But if you're talking about sheer high throughput system altogether, then of course you have to go for Kafka. The Ganga says, is there any change to the adjust the stream size means at a particular interval, assume for 10-second interval I want? Yes, so there are definitely batch configurations. There are different kinds of configurations which can easily be done altogether, right? So there are some of the configurations which are so what is the difference between Kafka and Flume? Okay, yeah, so but as of now, Ganga, all I can just say is yes, all of these changes can easily be done now, because there are other questions also. Devender has another question wherein he says, what is the difference between Kafka and Flume? Well, there is a huge difference, Devender. When it comes to Kafka, it's a distributed queuing system, right? Whereas when it comes to Flume, it's not a queuing system, it's not a messaging system, it's a data ingestion tool from Hadoop ecosystem, wherein you bring the data from various servers and dump it to an HDFS sink. You're talking about persisting data into HDFS via different channels. I hope you got it, right, Devender? That's a primary difference altogether, right? Does Kafka producer can get the data from Oracle? Yes. Pari, the answer is yes. I mean, in the interest of time, that's the shortest answer I can give you, right? Well, how it works, I think probably this is just a repetition of that small slide which you just saw some time back. It's all about, you are talking about, all of the arrows which are being pointed towards Kafka. They are the different producers. And I think Pari and others, you can clearly see that these are the, different producers which are publishing their data, right? They in the form of topic. Now this could be any of the sources, right? Any tracking proxy, any of the front-end systems, or in fact, as far as it might even be, let's say, a simple PL/SQL process altogether, right? Which is just publishing it, or simply just putting it in the form of a file, and that acts as a producer altogether. And then when it comes to the service or the subscribers altogether, again, it can be any of the systems, be it your data warehouse systems, be it your Hadoop platform and all. So all of them can be the subscribers. At the first look altogether, I'm just quickly, output arrows will be for Spark. They can be for Spark. The right word is they can be for Spark also. Okay, so you will just see that very quickly in few more slides. Well, who is who? So the terminologies which I just used, right? I just want to clarify those terminologies. Producers, you'll hear these terminologies very quickly. The producers, brokers, and consumers, and topics, right? And then partitions altogether. Producers is any system which produces the data. Okay, now comes the brokers, right? So brokers, you can just think of them as the channels altogether, right? So these are the different channels, right? In the case of Flume, you have different channels altogether, right? Similarly, in Kafka, you have the brokers which are responsible to publish the topics, right? And the topics are the logical separation of the different kinds of feeds which are coming from different producers. That is something which differentiates her. And then the topics themselves can be split into the different partitions which are replicated. So it's like your failure and recovery part altogether, right? That now you are creating the partitions altogether for each topic so that you have the failover capabilities also built up. And this is again from the logical perspective, this is how the topics would look like. Let's say topic, what exactly the topic is. Topic is just a feed name. It could be any name, right? It could be Vishal, it could be whatever name you want to give, any logical name altogether. For that topic, whatever would be the new messages. So of course it would just be a queue of from old message to the new message, and producers always can append the data to the tail. Always, it's like like writing to a file, right? If you write it, you can always write it to the latest offset altogether, right? And the same way, if there is a Kafka topic, you always have a queue, and that queue, each and every producer can put the data into multiple topics, but only at their tails altogether. Then you have the different brokers. So let's say this is how it might just look like. Let's say you have multiple producers who are producing the data, who are just appending it continuously, right? Then comes now probably Ganga, I think we were just talking about it, right? That your batches or the different heads, right? Head is like your old data. Those data can be pruned based on based on the age, based on the maximum size which you have set for a topic, or even based on the key itself, right? So that is something which is kind of configurable for each and every topic. And then comes the different consumer group, right? The consumer groups, each and every consumer group will have their own offset pointer. Offset pointer will just talk about what all messages they have read so far and how many messages are auto reset parameter exactly. So all of them all of the consumers can read their data from the very same topic from the different offsets altogether. So that is something which is there. Each topic, of course, each topic will be consisting of different partitions, and partitions are always ordered and immutable. Remember, they are immutable. You cannot really change any of their content altogether, right? Again, number of partitions of a topic, yes, it is configurable, because some of the topics might be more sensitive than the other topics, right? So but we have to change the group ID, of course. Yes, Ganga. So that something goes without saying, right? But yes, I'm assuming that you have some of the context of Kafka. Exactly, your point is correct. Rahul has another question wherein he says, if we do not need real time, I can use Kafka to insert into HDFS or HBase. What other tool will be required in addition to Kafka if we don't have Spark? Well, then I would say, Rahul, it's about solutioning, right? If you're talking about that you do not have this use case, then why do you even want to go for Kafka? Use something like, as somebody was saying, Flume, right? Just dump your data somewhere in SDFS, then use it, right? Pari, I answered it sometime back. I'm not sure whether you heard, but does Kafka producer with Oracle SQL Server table integration using GDBC connection, or Kafka producer has a tight integration with Oracle? No, it's not about tight integration. It can take the data from these producers. It's not the tight integration altogether, which we are talking about, right? Pari? I kind of answered this question. I think you typed it earlier also, and I answered it some time back. There was a question, how long will this class go? Guys, it was supposed to end by 9:30, but we had the disruption for almost 8 to 10 minutes, and hence we are just going for under 10 minutes, not more than that. All right. Okay. Yeah, I was just coming to the different partitions. So the partitions of each and every topic altogether is something which is configurable, because some of the topics might be more sensitive than the other ones, right? And it's all about the maximum copies which are there, and it's about, let's say if you have a simple Kafka cluster, you have different servers, you have different partitions altogether, and then each and every partition can serve to different consumer groups altogether, right? So this is just from the logical perspective. thing. Offset, the term which we said offset. Offset is nothing but it's like the messages in each partition, which are, in each partition, they are assigned a unique or sequential ID. We typically call that as offset. And consumers track their pointers, right? Always based on the tuples of offset, the partition, and the topic. This combination makes each and every message as unique. That, let's say you have consumed a particular message, right? How do you know, or how do you make sure that this combination is not picked up again? It's all based on, it's kind of composite key. It's all based on these combinations of offset plus partition topic. Based on that, the uniqueness of message is decided. The same message is not played again. So it basically guarantees you back one time this time, right? And basically this is this particular slide, which is the slide number 23. It effectively talks about that, right? That a partition, basically it's just a combination of your partition, offset, and topic, which is kind of uniquely defining a particular message. Okay, then comes does it require a zookeeper to keep the track of? No, Upender, no. This is where your individual consumers. So what are going to be your individual consumers? Your individual consumers are going to be the different systems, and it becomes their responsibility. It's not the responsibility of Kafka, because it just follows, I just told you, right, that it follows a publisher and subscriber mechanism. You just publish, and whether you want to consume it or not, that becomes the responsibility of a subscriber of a particular topic, of a particular partition. Is that clear? Whether they want to apply zookeeper or not, that completely depends upon the kind of consumer which is consuming. For example, Spark doesn't need it. Storm, it uses it internally. Got it? Did I answer your question, Upinder? Right? Because when it comes to Storm and all, they definitely would be using their own spouts altogether, right? So that is something which is there. Now, as exactly I was so this particular slide also just talks about it, right? That the brokers are not going to push the messages to the consumer at all. This is not the responsibility of Kafka. Its responsibility is just to publish. Now it becomes the responsibility of the consumers, which keep on polling the messages from a broker based on the topics or the partitions for topics and partitions for which they have subscribed altogether, right? So on a logical level, this is how probably the things look like. Let's say you have a producer, it has just a different name, then you have different brokers, and then from there, that red and greenish, they are the different partitions where your topics are there, right? And your consumers can be just be taking the data from a different partition, from a different topic combination. And I hope you are realizing at the same time that the combination of partitions and topic basically eventually leads to the scalability side of it, right? Because now you are not overloading a single partition altogether. And at the same time, their combination is ensuring the uniqueness of the consumption pattern altogether, right? Well, coming to the last part of the presentation, it's about, even though it says Kafka plus Spark is equal to real-time analytics, well, I would like to, and I think somebody was even asking about that, whether the Lambda architecture and other stuff would be covered in the course. Yes, of course it would be covered, but let me just don't take the slide as the case of saying that, how exactly I can use Spark with Kafka. It's about how exactly you can consume or how exactly you can use Kafka in the analytics system altogether. So typically you have the data, again, when it comes to Hadoop or even Spark, the best kind of file system is going to be your distributed file system, that is your HDFS. And again, you will always have cold path and hot path. I hope the cold path, as the name says, it's basically the path from where your batch analytics job are gonna run. right? Typically this path would be a kind of a consolidated view which is being consolidated at a certain frequency. Whereas your hot path is all about whatever has happened, let's say in some recent time. Example, the best example of this might be a banking system altogether, wherein you get a consolidated view of all of the transactions up to the last working day, and then in the business hours, let's say since last 1 hour or 2 hour, what exactly has happened. That is something which can be dumped in the hot path, wherein Spark is the right candidate, because this is the guy. And again, when you talk about Spark, it might be Spark streaming, it might be core Spark program or something. It's all about Spark would always provide you the that delta view. And this is something which we mean by the Lambda architecture, wherein your batch path is driven by Hadoop, and when it comes to your the other path, which is the latest view, is driven by Spark, right? So we typically call this as a Lambda architecture, and eventually your web application fetches the data from both, because it is just the view layer altogether, right? Where it is just gonna fetch the data. So you will always have a consolidated view as of last run, and then a view which talks about whatever has happened latest. That is something which is going to be available as a kind of a separate report or as a separate section altogether, right? So when it comes to the data ingestion source for Spark, or for that matter any of the Hadoop jobs, it could be any of these things, Kafka, Flume. Well, I think it needs some action. When you come to Twitter can be an agent for your Flume or Kafka, and you don't, or you decide to let's say consume the data directly from their API, you can do that, but not suggested, right? Or you might just be consuming the data from HDFS or even Kinesis or some other system altogether. Eventually, Spark streaming is a generic system, guys. So Spark streaming doesn't, please do not, again, do not couple your understanding of Spark streaming with Kafka. Kafka is just one of the sources altogether, which can fit in the entire bigger Spark streaming application altogether. And eventually Spark streaming application, as I said, that streaming applications are typically different from your normal applications of Hadoop, which typically work towards processing the data and persisting it. Whereas when it comes to Spark can go for persisting, or can simply just process the things and just throw it back to the dashboards, and that's it. No persistence. In fact, that are the best use cases for Spark. Just keep on processing the data, do some windowing operation, and then leave it. Because persistence is something, if you really want, probably you would like to go for something like Hadoop or something, right? So that is the place wherein you see where Kafka sits. Kafka sits as just as a single one of the data sources for Spark streaming, which is consumed by it, right? Now Spark streaming detail. So again, it's in a different direction when we talk about Spark streaming. So guys, eventually so yeah, Rahul, just a second, let me just complete a few things. So Spark streaming, at the end of the day, see, whatever you do in Spark, right, that is created or that is done on something called RDD, Resilient Distributed Data Set. Okay, and when it comes to the Spark streaming, it uses a specific kind of RDD that is called dstream or discrete stream. Okay, it is nothing but it's a batch of small RDDs which are created over a certain period of time. That period of time is something which is configured by the users for a certain set of applications. So for example, you can say that my Spark streaming job is gonna continuously look input. This input data might be coming from Kafka, this input data might be coming from a particular console program, or just let's say or even for that matter from any of the, let's say JMSQ itself, or let's say from a Flume sync path altogether. So it just keeps on looking at that input path, right, for the configured time, and whatever is that data which is created, it just processes it. So these are Spark streaming applications are typically used for windowed kind of operation. Let's say you must have heard about some of the like windowed word count, or windowed word count is a very rudimentary example. You have windowed operations like uh, uh, the trending topics in last 1 hour. Facebook is the biggest example. I hope you guys would have noticed those things, right? So these are few things which are the typical use cases of Spark streaming, and Spark treats this input data which is continuously flowing from, in case of Kafka, it is continuously gonna flow from a given particular partition of a topic, right? So these are few things, right? Kapil, I think I'm just gonna complete now. So Kafka helps build lineage? No. The simple answer is no. Kafka is just gonna publish the data. Now lineage and all is still the part of RDD. Got it? How to run multiple Spark streaming receivers to to consume Kafka messages? Well, Pari, I think answer should have been very clear in terms of configure the different your Spark streaming receivers to different your Spark your Kafka topic and partition ID. That's it, right? So that is something which is, and I think since we are already over the over time itself, so I would just try to kind of so this hands-on part, definitely I would have loved to do it if we would be there within the time, but unfortunately we are already running over the time. So instead of that, I would like to kind of entertain if there are some questions which I can see or I can respond there. Kafka adoption and use cases. Well, again, this is something more, not a concept. This is more of a information. These are the different companies. You talk about most of the companies which are basically going to deal with your lot of activity data, which have to track all of each and every of your activity. They cannot avoid Kafka. That's the kind of statement which I would like to give at the end of this presentation, right? With that, guys, I think the session comes to an end, and I hope, like, I clearly saw quite a lot of questions from Ganga, a few questions from Rahul, Pari, others. Guys, of course, this is a limited period of time, which allowed me to do a very quick kind of interaction with you. But I hope you got some of the answers, right? If not all, at least, or some of the pointers and all, right? So with that, I hope it has helped you in some way. And with that, I would like to take your leave now, right? Thanks a lot for being patient when there was a disruption also, right? And yes, if it excites you, see you there in our Kafka batch altogether, right? Sure. Can we get the slides, please? Yes, you are definitely going to get the slides for sure. They are all going to be uploaded. They're all going to be uploaded. Okay, guys, with that, leaving now, taking your leave. Bye. Bye for now.